For a constant force F, suppose the duration of impact of an object is doubled. So time is doubled, time is times 2. How does this affect the impulse? Well, if we're doubling time and we're keeping force constant, that's twice the impulse, or 2j. How does this affect the change in momentum? Change in momentum and impulse are the same thing. So if we're doubling the impulse, we're doubling the change in momentum. It's 2 times larger. Number 2, we've got a mass of 0.5 kilograms football thrown by Vince Young with a initial velocity of 15 meters per second, caught by a stationary receiver and brought to rest, so the final velocity is 0 in 0.02 seconds. What is the impulse delivered by the ball? We know impulse is force times time, and it's also change in momentum, mass times the change in velocity. Using either side that we have the information for, we can solve this. So 0.5 times v minus v naught, or 0 minus 15, which would be negative 75 Newton seconds. What is the impulse delivered to the ball? Impulse is force times time. We solved for the change in momentum, so we've got negative 7.5 is equal to force times time. Plug in the time at 0.02, divide that over, we get negative 375 newtons for the force. Going to number 3, a 1,500 kilogram Maserati moving with a speed of 15 meters per second collides with a utility pole and is brought to a rest in 0.3 seconds. We are given the mass, initial velocity, final velocity, and time. Find the force, which is the only thing we were not given, exerted on the Maserati during the collision. So we've got force times time, or F times 0.3, is equal to mass, 1,500, times the change in velocity, final minus initial, 0 minus 15. We can take 0 minus 15, multiply by 1,500, then divide the 0.3 over, and we get a force equal to negative 75,000 newtons. What effect would the extended the time of impact have on the force exerted on the Maserati? Well, we know the impulse is the same. The impulse is going to be the same. They're still going from 15 to 0, so increasing the time will decrease the force. Force times time is going to equal the same impulse, so they're inversely related. If you increase the time, you decrease the force. Number 4, a soccer ball of mass of 0.4 kilograms is approaching David with a velocity of 15 meters per second in horizontal flight. Illegally, David strikes the ball with his hand and causes it to move in the opposite direction at 22 meters per second. Keep in mind that's an opposite direction, so we have to have an opposite sign here. David produces a 14,800 Newton force on the ball. How long is his hand in contact with it? We have force times time. We know the force is negative 14,800 because the force is going to cause it to change direction, so we're going to make it a negative force. Times time is equal to mass of 0.4, and then the change in velocity, the final velocity is negative 22 because it changed direction, and then we're going to subtract the initial velocity of 15. Negative 22 minus 15, and then multiply by 0.4, dividing the negative 14,800 over. We get a time of, I'll let you catch up, we're going to get a time of 0.001 seconds. So very short time in contact. Number 5, an 8 Newton force acts on a 5 kilogram object for 3 seconds. We have the force, we have the mass, we have the time. In the direction the object was originally moving, what impulse is given to the object? Well, we know impulse is force times time, and we know it's also mass times the change in velocity depending on the information we're given. We were given force and a time, 8 and 3, so 8 times 3 is 24 seconds. The unit of impulse being Newton seconds because we're multiplying force times time. So that is our impulse. What change in momentum does this impulse cause? Change in momentum is impulse, so it's 24 Newton seconds. What is the final velocity? Well, we know impulse or change in momentum can both be calculated or either be calculated as mass times the change in velocity. So we're going to take our 24, set that equal to the mass times the change in velocity. So we have 24 is equal to the mass times v minus v naught. 24 is equal to 5 times final velocity minus initial, v minus 25. We can distribute the 5 inside the parentheses and get 24 is equal to 5v minus 125. Add the 125 to the other side, and then divide by the 5 that's in front of your velocity. And when we do that, we should get 29.8 meters per second for the final velocity. Going into number 6. Number 6, a 20,000 Newton truck is acted upon by a force that decreases its speed from 10 meters per second to 5 meters per second in 5 seconds. What is the force? Well, if we're starting with a 20,000 Newton truck, that's its weight or force of gravity. If we take the weight or force of gravity and divide by 10, we would have the mass. So 20,000 divided by 10 should give us 2,000 kilograms. Taking the weight divided by 10 gives us the mass, because we know mass times 10 is the force of gravity, which is the weight. Now that we have the mass, we're going to see what else we have. We had the initial velocity of 10 meters per second, final velocity of 5 meters per second, time in 5 seconds. Force times time is equal to mass times the change in velocity, final minus initial. So force times 5 seconds is equal to mass of 2,000 times change in velocity, final minus initial, 5 minus 10. 5 minus 10 is negative 5, times 2,000 divided by 5 is force of negative 2,000 newtons. And we can anticipate the force being negative because it's slowing the object down. If the object's moving at a positive velocity, a negative force would cause a negative acceleration, slowing it down. Final answer, negative 2,000 newtons for the force. Turning our page over, going to the backside, we've got an object that is an 18,000 kilogram van containing Lex Luthor is moving with an initial speed of 15 meters per second. If Superman is to stop the van in 0.5 seconds, what force must he exert on the van? So we know the final velocity being 0 because it's coming to a stop. Force times time is equal to mass times the change in velocity. Force times 0.5 is equal to 18,000 times 0 minus 15. And then when we do the math with 0 minus 15, negative 15 multiplied by 18,000, divide by the 0.5 on the other side, we get a force of negative 540,000 newtons. Number 8. A 2,000 Newton force acts on a rocket of mass 1,000 kilograms, increasing its speed from rest, initial velocity 0, to 200 meters per second, final velocity being 200 meters per second. How long did the force act? Well, we know force times time is equal to mass times the change in velocity. The force of 2,000 times t is equal to the mass of 1,000 times the change in velocity, final 200 minus initial 0. 200 minus 0 is 200 times 1,000, and then divided by 2,000 from the other side gives us the time of 100 seconds. Number 9, you can't throw a raw egg against a wall without breaking it, but you can throw it at the same speed into a sagging sheet without breaking it. Explain why that would be true. Well, a sagging sheet will increase the time of impact, meaning when it hits the wall, bam, it stops immediately. But when it hits the sheet, it doesn't stop immediately. The sheet moves. So it takes a little bit of time for that impact to fully occur, to go from whatever initial velocity to 0. So if you're increasing the time of impact, you're reducing the force. We saw that relationship early in the worksheet, and we know that the impulse is the same. The initial velocity is still set. The final velocity is still 0. So if we can increase the time, we're decreasing the force because the product is still the same. Number 10, a bug and a windshield of a fast-moving car collide. Indicate whether each of the following statements is true or false. For the false statement, explain why. For number 10A, the forces of impact of the bug and the car are the same magnitude. That is true. Newton's third law tells us two objects interacting will share the same force, but in the opposite direction. 10B, the impulses on the bug and the car are the same magnitude. True. Impulse and change in momentum are the same for the bug because they're sharing the same force and they share the same time of impact. So force times time is impulse and change in momentum. 10C. The change in speed of the bug and the car is the same. Well, we know that's ridiculous. So false. The bug has a smaller mass and therefore will have a larger change in speed. The car has a larger mass and therefore will have a much smaller change in speed. D, 10D. The changes in momentum of the bug and of the car have the same magnitude. This is true. Impulse and change in momentum for the bug and the car are the same. They experience the same force. They experience the same time of impact. Force times time is impulse, which is also change in momentum. When we look at the change in momentum side, because of the differences in mass, we'll have differences in change in velocity, but the product will still be the same. Going to number 11, an object of mass 2 kilograms experiences a force according to the force time graph shown here. Looking at the graph, we can see the force is always positive, going from 0 to a positive value back down to 0, never negative. What's the total change in momentum of the object? Well, change in momentum is impulse, which is force times time, so we're looking at the area under the curve. I've divided the curve into 3 parts, 2 triangles and 1 rectangle. The area of a triangle is 1/2 the base times the height. The area of a rectangle is base times the height, so I have 1/2 times 10 times 2 plus 2 times 10 plus 1/2 times 10 times 1. When we multiply those out and then add them together, we get 35 Newton seconds. If the object started with a speed of 5 meters per second, how fast will it be moving at the end of the 5-second time period? Well, we know we've already calculated the impulse or change in momentum at being 35. We can set that equal to mass times the change in velocity. Mass is 2, initial velocity is 5. We're just calculating for the final velocity. 35 is equal to 2 times v minus 5. When we calculate that and put that together, we get 22.5 meters per second.